Alrighty, today we're doing 14.1b, applications of exponential decay. So it's similar to yesterday, except for these things are declining instead of growing. So just recall that exponential decay is a number between 0 and 1, so it's going to be a proper fraction, alright? 1/2, 1/3, anything where the numerator is smaller than the denominator is a proper fraction. Again, the initial amount is the C naught, and A is equal to the common ratio. I love math. Okay, in 2016, a 2-year-old 2004 model SUV, the Bland Grover, somebody's funny, sells for $27,000. It appreciates, or depreciates rather, it loses value at a rate of 12% each year. So this isn't a classic car like yesterday's lesson. A classic car appreciates in value, so it's gonna, like if it's like a 1940 Ford Model T, nowadays that's like so awesome to have because it's so rare, so it's gaining in value. However, if you have a 2014 Bland Grover, that's going to depreciate. Any car actually, if you buy a car new, pretty much like the second you drive off the lot, it loses 40% of the value, I believe. So we don't buy new cars in our family. Anywho, side note. Okay, so it depreciates at a rate of 12% each year. We have to be careful about not using 0.12 as our ratio. We want to keep track of the actual value, not how much it loses. So if you were at 100% and then you lose 12%, you are retaining 88% of your value each year. Therefore, our common ratio will be 0.88, which we can always get by subtracting the percent of depreciation from 1. So we're going to make a table for this and graph it, and just like yesterday, we have 3, 5, 7, 9, 11, and 13. And if you're like, Wilkin, why does this say year 2? Well, remember, the car is 2 years old, so we don't have the amount at 0, okay? So let's go ahead and plug these into our calculator in just a second. This is going to be decay, like I said, and if it's decay, it's 100% minus the 12%, which gives us 88%, or 0.88. Another way to do this is 1 minus 0.12, and that gives you 0.88 as a decimal. All right, so let's type these in. So we have 27,000. They told us that's the original value. To find out the next number, I'm going to multiply by 0.88. So that gives me 23,760. That's a good thing because it should be going down in value. Not drastically, but down. So then I'm going to multiply that by 0.88. And then I get this number right here. We are rounding it to whole numbers, so 20,909. Then multiply that by 0.88, 18,400. And now we are going to just fill the rest of this table out. You guys know to find the next number, I just keep multiplying these by 0.88. Okay, so here we go. This is what we get after 14 years. That Bland Grover will only have a value of $5,823. But then this table all of a sudden jumps to 1. So I'm going to draw a line there because I don't want my brain to think the pattern continues, because these numbers were going up and now they're not. So the question is, how do I figure this out? So in order to go from one value of the year to the next, I multiplied by 0.88. But if I want to go the other way, then I just divide by 0.88. So let me show you with the year 3 and the year 2 one, if I do 23,760 divided by 0.88, that gives me the 27,000, right? So if I multiplied it going one way, I'm going to divide it going the other way. So I'm going to start with year 2 because I'm going down to year 1. So 27,000 divided by 0.88 gives me the value after 1 year. And then I'm going to go from there, this is actually a 2, and divide by 0.88. I would argue that this isn't entirely accurate, that you bought the car for the money that's right here. I don't know if you can buy a bland Grover for this much, but like I said, you lose so much right after you drive off the lot that that's probably not accurate, but we'll go with it, all right? So let's go ahead and plot these points and see what's happening. At year 0, which is down here, we have 34,866. And then I'm going to go to year 2 because I don't want to plot all these points, is 27,000. Year 4 is about 21. Year 6, 16,000. Year 10, ooh, you're dropping in value, buddy, real fast. Let's do year 8 first, though. And then year 10. And then year 12. Okay, so this one is coming down, 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 and it's going to coast along that asymptote. It's never going to get to 0. So the question that we're asked is to write the function for this. So f of x equals the initial amount, which in this case it's telling us it's 2,000 because they talked about that up here, okay? And then what's our rate? It is 0.88, and actually I'm going to go back here and write 0.88 because I'm pretty sure my HRW wants to write that. And then I'm putting x minus 2. And you're like, wait a minute, where did this minus 2 come from? Well, remember, this was the second year, not the first year, not year 0. So since this was the second year, this is the equation that's representing the problem that we've given right here, okay? So again, I just want to point this out, whatever value this is, so this was the value for the second year, that's the number that goes here. So if I put in a value of 20,909, which is the value at the fourth year, I would put a minus 4 up here, okay? The reason why we're doing 2 is because the problem is saying it's a 2-year-old vehicle, so our time 0 starts at the second year. Okay. How can you determine the car's value in 2015? So we just did that. We did 2015. We took 27,000 and we divided it by 0.88. But we also have a formula, so we can go, or we can do f of 1, because that's the first year, equals 27,000 times 0.881 minus 2. Okay? And that's when we got this value right here. So that equals 30,682. What is the original value when the car first sold in 2014? So that's f of 0. We already know this value. It's right there. We figured it out. So that's going to be 27,000 times 0.88 to the 0 minus 2. I keep forgetting to put the 0 in front, but my HRW likes that 0 in front of the decimal place. And that gives me, when I plug it into my calculator, 34,866. It says fill in these values for year 1 and year 0 in the table, but we already did that. Next, with your calculator, can you figure out to the nearest year approximately when the value of the car will be half? Okay, so 27,000 divided by 2 gives me 13,500. You can use your calculator for that, but let's just go ahead and look at the table. So here 13,000 is like between 7 and 8, so we'll just call it year 7. Alright, so that was the car example. Now we're moving on to another example, which is bacteria. The amount of harmful bacteria in a patient gets reduced by 20% each day they take the correct dosage of antibiotics. What percent of harmful bacteria will remain after they take the correct dosage for 5 days? Since we don't know the actual amount of bacteria, we will just use 1 to represent the entire amount of infection. So you were 100% infected, I guess. So here we go. Common ratio. So you were 100% infected, and then we are subtracting the 20%. So 0.20. So our common ratio is going to be 0.80 or 0.80. All right. So f of x equals the 100 times 0.80 to the x. Okay, so our initial amount will be 100, and then 0.8 is the common ratio raised to the x, and then we need to know the percent remaining after 5 days. So we plug in 5. Boop, 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 boop. Into our calculator, we get 32.8%, which is what will be remaining. So let me go back and talk about this 100 really quickly. The question says what percent of the harmful bacteria will remain, and they're telling us to use 1 as the amount. So the initial amount as a percent, if we're going from a decimal to a percent, we're going to go 2 to the right. So 1, 2. So that's 100% of the infection. That's where that 100 came from. All right. In the movie I Am Legend, that's got Will Smith in it, a highly infectious disease sweeps the world and decreases the population drastically. If the population decreases exponentially at a rate of 30% each month, determine the following. The population percent equation. All right, so first of all, we need our common ratio. So that's going to be 1 minus 0.30, which equals 0.70. So this is going to be f of x equals 100% of people were alive, and then we lost them at a rate of 0.070 to the x. Okay? What is the percent remaining after 5 months? So we're going to plug in 5. And we're going to get out our calculator and do 100 times 0.70 raised to the 5th power. So we got 16.8% after 5 months. Only 16.8% of the population is remaining. Now, again, this is a little bit tricky because the answer is asking it for a percent. Whenever we put in a common ratio, the common ratio is always as a decimal. But you have to read the context clues to know about this guy right here. So 100% of the population was there, and then now it's decreasing to only 16.8% of the population. What about after 1 year? So you do not want to do f of 1. That is not a good idea to do. The reason why is because this says that it's based upon months right here. So 1 year is 12 months. So make sure you write that. So f of 12 equals 100 times 0.70 raised to the 12th power. So back into my calculator I go, and I get after 12 months, only 1.4% of us are surviving. Yikesies. Okay, next one says the percent remaining after 2 years. And 2 years, there's 24 months. So again, I have to do months because that's what the problem says. So f of 24 raised to the 24th power. And after that time, it's so sad, only 0.019% of us would be alive if somebody didn't figure out a way to stop that harmful bacteria. Alrighty, that's it for today.